Hello everyone, my name is Dr. Coca, and in this video we're going to be completing the dehydration of 2-methyl cyclohexanol experiment. So we have, through distillation, produced an alkene mixture which we later purified with an extraction. At the end of that video, you might recall we had our alkene product in sodium sulfate. So since then I have transferred our product from this flask, which has still the sodium sulfate in it, to a new pre-weighed Erlenmeyer flask. So in the second Erlenmeyer flask, we only have the alkene product. It should be dry now. It should be fairly pure. Since I know the weight of that flask, I also know the weight of our product, and we can calculate the percent yield from the reaction based on that weight. So your instructor will also provide you a HNMR spectrum that will allow you to confirm the structure of the product. So the last part of this experiment involves doing some very simple chemical tests to test for the unsaturation or the presence of an alkene in our product. So the first of these tests will involve bromine. So for that, I have taken 2 test tubes. In one, I placed 5 drops of our alkene product. In the second test tube, I placed another 5 drops of the alcohol 2-methyl cyclohexanol, which was the starting material for this reaction. To each of these test tubes, we're going to add bromine. So we're going to take a 2% bromine solution in dichloromethane, which, as you can see, is a sort of red-orange color. Our product is colorless, and if we start to add drops of the bromine to this mixture, one at a time, you can see that nothing is really happening as far as color to our product in the test tube. So no matter how much bromine we add, this solution remains a colorless solution. If we try to do the same to our alcohol, again, there's a few 5 drops of that alcohol in here. Let's see what happens. So if we add 1 drop, immediately you see a yellow color with the alcohol test tube. This yellow color essentially is the diluted solution of the red bromine solution we added to it. So you want to look at the reactions that can potentially happen or not happen in this experiment. So those you'll find in the introduction of this experiment, and think about what reactions are or not, or what reactions are or are not occurring when you add bromine to these 2 test tubes. So the second and final unsaturation test involves potassium permanganate. So this is called the Bayer test. So potassium permanganate is a a purple solution, and we're going to be adding that to 2 test tubes as well. So the first of these test tubes has about 5 drops of our alkene product. It is mixed in with 0.3 mL of dimethoxyethane. And in the second of these test tubes, we have another 5 drops of, in this case, the alcohol that we use as the starting material for this experiment. That one is also mixed in with dimethoxyethane. The purpose of dimethoxyethane is to it's basically act as a solvent to mix the potassium permanganate and our reactants. So if we take our first of these test tubes with the alkene product and we add the purple potassium permanganate, start to add it, you'll see that immediately sort of a precipitate at the very bottom forms. Is slightly purple in color at this point. If we add some more, so we added 3 drops at this point. The solution is sort of a purplish color, but the precipitate at the bottom is sort of a brown color, and it's a lot easier to see if you give it a couple more seconds, and especially when you compare it to our last test tube. At the very top is there's sort of a purple color, but the precipitate itself is a brownish color. Okay. This is our last test tube. It contains, again, the alcohol. Starting material is a colorless liquid. We add the purple potassium permanganate to it, 1 drop at a time. So that's 1 drop, 2, 3, mix it in. And you can see the whole solution is still sort of a deep purple color. If you compare that to our previous mixture, which is currently on the right on this side, you can see that there is a brown precipitate. The mixture itself is sort of a brown color. And so there's a stark difference between these 2 test tubes. So the alcohol remains a purple color. The alkene turns into a brown precipitate. So once again, you want to think about what reactions are occurring in this particular experiment or not occurring, and comparing that to what the functional groups are that we're mixing, the potassium permanganate, and in the previous case, the bromine, to sort of think about those.